In this example, we're going to find what is the energy stored in the circuit. So basically, we know that resistor converts electrical energy into heat energy or light energy. Capacitor store energy and inductor store energy. So basically, we are trying to find what is the energy stored in this inductor, what is the energy stored in this capacitor. Okay, so what is the formula for energy stored? So formula for energy stored in capacitor equal to half CV square, energy stored in the capacitor, energy stored in the capacitor. What is the format? So energy stored in the capacitor is in the electric field, in the form of electric field. So if you have a capacitor, there is always electric field between these two plates. It stores energy in the form of electric field. That's basically physics. Don't need to worry too much about this at this point. You must know all these things from the physics. And energy stored in the inductor is half Li square, that is energy stored in the inductor. Okay, now you need to know the behavior of the inductor and capacitor in DC. Is it a DC circuit or AC circuit? Here it is a DC circuit. How do I know it's a DC? Because of the given source values. So here the source voltage 20 volts and 10 volts look like they are DC. If it is AC, usually you will see a sinusoidal waveform, or at least you will see angle, something like that. This is the AC source. Here is the AC source. DC source, you will see plus and minus with the only magnitude, no phase angle. Okay, so this is a DC circuit. So in DC, once capacitor is fully charged and inductor is fully energized, they act like a open circuit or closed circuit. Okay, how long does it take to act like open or closed? Few milliseconds. Or how long does it take to charge the capacitor or inductor? A few milliseconds or microseconds. So once in DC circuit, once capacitor is fully charged, it acts like a open circuit. Okay, so in steady state, capacitor act like a open circuit, and in DC circuit, once inductor is fully energized, it acts like a closed circuit or short circuit. Short circuit is the right word. So in DC, once capacitor is fully charged, it acts like open circuit. Inductor act like a short circuit. So in this case, I'm talking about the steady state. Okay, it's always steady state. I will never talk about transient state in the exam, because transient state is only few milliseconds or microseconds, less than a second. Okay, so we don't need to worry about the transient state. Until unless I specify transient state, we always talk about steady state. So I would mention, yeah, steady state means it's once it is fully charged. That's what it indicates. Okay, I'm going to redraw the circuit diagram here with these parameters. So here is my circuit: 20 volt, 3 ohm, inductor is going to act like a short circuit. Okay, here is my final circuit: 5 ohm, 10 ohm, 20 ohm. Now here my goal is finding this voltage. I'm going to label that as VC, and finding this current. Okay, I can use mesh analysis, nodal analysis, or whatever to find those parameters. Okay, here since there are two sources, for sure I cannot solve it by using series parallel combination method. I have to use either mesh analysis or nodal analysis. I'm going to use the nodal analysis. So I'm going to say that's voltage across that point is VC, and voltage here is 10 volts. Okay, now nodal analysis is nothing but we're going to take apply KCL at VC. Apply KCL, Kirchhoff's current law, at VC. I'm going to take every current is going out of the junction. Okay, that's I1. I'm going to take this as IL. I'm going to take this as I2. So I1 plus I2 plus IL equal to 0. Now, is it possible to have every current is leaving that junction? No, for sure at least one of the current is coming in. So for sure at the end of the, once you calculate I1, I2, I3 or IL, your one of the current is going to be negative. In this case, most probably I'm guessing my I1 is going to be negative because I have voltage source there. Now the voltage at this point is 20 volts because the voltage here is 0 volts. I always tell you this all the time. So here is an element. It could be an inductor, capacitor, resistor, A, B, VAB. So VAB equal to VA minus VB. So in this case VB is 0, VAB is 20, so you'll find VA, which is 20 volts. So at VC apply KCL. So I1 equal to VC minus 20 divided by 3. I always take every current is going out because the reason behind this is it's easy for me to write the equation. So it's going to be VC minus something divided by resistor, and I2 is VC minus 10 over 20 plus VC minus 10 over 10 equal to 0. I just want to make sure that there's 3 ohm. Okay. Now to eliminate the denominator, I'm going to multiply this with can I multiply this with 60? Okay, here I'm multiplying with 60. So if I multiply with 60, 60 divided by 3, 20 VC minus 20 times 20, 400. 20 divided by 60 divided by 23 VC minus 30 plus 6 VC minus 60 equal to 0. So I have 20, 23, 29 VC equal to 490. VC equal to 490 over 29, that equal to, okay, that value equal to 16.89 volt. So this is nothing but the voltage drop across capacitor. Now we'll find IL, the current passing through the inductor. IL equal to VC minus 10 divided by whatever that resistance value. I have 10 volt. That must be 16.89 minus 10 divided by 10. 6.89, so it's 0.689 ampere. So what is the energy stored in capacitor? UC, or you can say EC, or you can say WC. Some textbooks uses U, E, W, doesn't matter. Half CV square, half time, what is the C value there? The given C value is 0.1 millifarad. 0.1 times 10 to the power of minus 3, 16.89 whole square. At the same time, energy stored in the inductor, UL equal to half Li square, half time, what is the inductance value? The given inductance value is 2 Henry. I square is 0.689 whole square, that equal to, okay, so the energy stored in the inductor is 0.474 joules, and energy stored in the capacitor is 14.274 millijoules. Thank you.